Section 7.5, Solving Square Root and Other Radical Equations. A radical equation is an equation that has a variable in the radicand or a fractional exponent. A square root equation is when the radical in the equation has an index of 2. Recall from previous sections, we can have some extraneous solutions. That is a solution derived from the original equation, but is not a solution of the original equation. In other words, we have to test all solutions to make sure they are actually solutions of the original equation. Here's our procedure. First thing we want to do is isolate the radical on one side of the equation. 2, we want to raise both sides of the equation to the same power. And 3, substitute the solution or solutions back into the original equation to determine if any are extraneous. Or in other words, don't solve the original equation. Here's our first example. Step 1 is to isolate our radical. So to do that, we're going to subtract 3 from both sides. That gives me the square root of x minus 1 equals 2. Now I want to take the square of both sides. Square of a square root leaves us what's on the inside, which is x minus 1. And on the right side, 4. That gives me x equal to 5. We want to substitute this value back in. 5 minus 1 is 4. The square root of 4 is 2. 3 plus 2 is 5. Therefore, that is our solution. Let's take a closer look at this step. Here I have x minus 1, and I have the square root of that. We know from a previous section that I could write that as x minus 1 to the 1/2 power, and that would equal 2. Our goal in this section to solve these types of problems is to get that exponent to equal 1. Therefore, what I did is square both sides, as I did in this section. Therefore, 2 times 1/2 gives us a good visual representation that would be x minus 1 to the first power, or just x minus 1, which equals 4. And eventually, I would get x equal 5. So our goal is to get that exponent, which is fractional, to equal to 1. Again, we want to isolate our radical, and -3 will come with us at this point. We'll simplify that out on the next step. That gives us a -3. The square root of 2. Subtract 6 on both sides gives me a -6. Now I'll divide by a -3. That gives me the square root of 2x equals 2. I know this is 2 to the 1/2, also the square root, so therefore I will multiply by a power of 2. Square both sides. That gives me 2x equals 4. Divide by 2, and x equals 2. Let's determine if that's extraneous by substituting back into the original. 2 times 2 is 4. The square root of 4 is 2. 2 times a -3 is a -6. A -6 plus 6 is 0. Therefore, that is one of our solutions. Here I want to solve 7x plus 5 to the 1/3 power equals 3. Recall that we know to the 1/3 power, that is the cube root of 7x plus 5. I always think it's easier to see the fraction, therefore I know what to raise that to a power to get that exponent to be 1. Here, since it's 1/3, I'm going to raise both sides to the 3rd power, or cube each side. When I do that, 3 times 1/3 is going to give me 7x plus 5, which equals 3 cubed, 27. Now I subtract 5 on both sides. I get 7x equals 22. And when I solve again, by dividing by 7 on both sides, I get 22/7. Now what I can do is substitute that value back in to make sure it's not extraneous. That's going to give me 22/7 times 7, or 22. 22 plus 5 is 27. And the cube root of 27 is 3, which is our original problem. Therefore, 22/7 is a solution. Our next example, I have 2x minus 6 to the 2/3 power plus 8 equals 12. Recall that that would have been the cube root of 2x minus 6 squared. But it's a lot easier to solve it as a fractional exponent. Let's isolate this quantity. That gives me 2x minus 6 to the 2/3 equals, subtract 8 on both sides, I get 4. I'm going to multiply this by the reciprocal of the fraction, which is 3/2. And when I multiply that, that's going to give me 1. But I also have to remember to do that on the other side, which is 3/2. Power to the power gives me 1. I get 2x minus 6 is equal to, and recall, this is going to be 4 cubed, and I know I can do this. Take the square root of 4, and that would be cubed. We can solve that from the previous sections. We know that process. Square root of 4 is 2. 2 cubed, I'm going to get 8. Therefore, this is going to be 8. That gives me 2x equals 14 when I add 6 on both sides. Divide by 2, x is equal to 7. I'm going to substitute back in. 7 times 2 is 14. 14 minus 6 is 8. And I know the cube root of 8 is 2, and 2 squared is 4. And 4 plus 8 is 12. Therefore, that is a solution of our problem. Again, in this example, I want to begin by isolating my quantity with the fractional exponent. I'm going to subtract 2 on both sides. That's going to give me 5 times 2x minus 1 to the 3/4 power. Subtract the 2 on both sides gives me 135. I'm going to continue by dividing by 5 on both sides. Gives me 2x minus 1 to the 3/4 equals, when I divide by 5, I get 27. I need to get my fractional exponent to become 1, so I'm going to take that to another power, which will be the reciprocal of that fraction, which is 4/3. Do that on both sides. Raise that to the 4/3 power. When I multiply here, that gives me an exponent of 1, which gives me 2x minus 1 equals, and we know that this is going to be the cube root of 27 to the 4th. The cube root of 27 is 3. 3 to the 4th is going to give me 81. Now I have 2x minus 1 equals 81. Add 1 to both sides. I get 2x equals 82. Divide by 2. I get x equal to 41. Now I need to determine if my solution is extraneous. So I need to substitute that back into the original. 2 times 41 is 82. 82 minus 1 is 81. 81 to the 4th root is going to give me 3. 3 cubed is going to give me 27. 27 times 5 is 135. 135 plus 2 is 137. Therefore, this is a solution of the equation. My next example, I want to determine the solution for this equation and determine if any of them are extraneous solutions. Again, I'm going to get my exponent, my fractional exponent, to be 1. This is a square root, therefore my fractional exponent would be a half. So I'm going to square both sides, or take it to the second power on both sides. When I do that, that's going to give me 3x plus 10 on the left. On the right, that's going to give me a product of 2 linear factors, x plus 2 and x plus 2. In this case, I need to FOIL, which gives me x squared. First, outer plus 2x, inner plus 2x, and last, which is plus 4. That gives me, when I simplify, x squared plus 4x plus 4. On a quadratic, I'm going to set to 0. I'm going to bring all of this to the right because my coefficient's positive. I'll leave it that way. So I'm going to take this to the right. Gives me 0 equals x squared. 4x minus 3x is going to give me a negative x. And subtracting 10 gives me a negative 6. Now I need to factor. That's going to give me x, and that's going to be a minus 3 plus 2. x times x is x squared, minus 3x plus 2x is a negative x, and a negative 6. Setting each linear factor equal to 0 and solve, I get x equal to 3, and x plus 2 equal to 0, and x equals a negative. Now I have to substitute each of these back into the original to determine if they are solutions or extraneous solutions. Let's substitute 3. 3 times 3 is 9, plus 10 is 19, but that's the square root of 19, equals 3 plus 2 is 5. They are not equal, therefore that is extraneous. Negative 2. Negative 2 times 3 is a negative 6, plus 10 is 4. The square root of 4 is 2, equals a negative 2 plus 2 is 0. They are not equal. Therefore, this is extraneous, and my solution is the null set. Again, we want to solve the equation and determine if there are any extraneous solutions. Let's begin by isolating our fractional exponent quantity. To do that, I'm going to subtract 21 on both sides and also add x. When I add x, I'm going to get x, and subtract 21, I'm going to get a minus 5. Now I'm going to eliminate my fraction by taking this quantity to a power of 2. I'll do that on both sides. When I do that on the left side, I'm going to get 4x minus 23. And on the right side, I need to break that into a product of its linear factors and FOIL. When I do that, I'm going to get x squared minus 5x minus 5x plus 25. I'll combine like terms and get x squared minus 10x plus 25. Since I have a quadratic, I'm going to set to 0. This is a positive coefficient of my biggest term degree. So I'm going to bring everything from the left to the right. That gives me 0 equals, subtracting 4x on both sides, gives me a negative 14x when I combine like terms, and add 23 is going to give me a positive 48. Now I need to factor. That gives me 0 equals x, and that will be minus 6 and minus 8. And when I solve these, that will give me x equal to 6 or x equal to 8. Now I have to determine if either of those are solutions or either of those are extraneous. Let's substitute back into the original. When I do, that's going to give me, I'm going to start with 6. 4 times 6 is 24. 24 minus 23 is 1. The square root of 1 is 1. 1 plus 21 is 22. And 22 minus 6 is 16. And it equals 16. Therefore, that is a solution. 8. Let's try 8. 8 times 4 is 32. 32 minus 23 is going to be 9. The square root of 9 is 3. 3 plus 21 is 24. 24 minus 8 is 16. And that is a solution. Therefore, these are both solutions of the equation, and none are extraneous. Again, we want to solve and check for extraneous solutions. Here I have two fractional quantities, both to the 1/2 power. To solve this type of problem, I want to eliminate one of these quantities and put them on the other side. And I'll have a quantity on both sides. So I'm going to keep my 3x plus 5 here. That gives me the quantity of 3x plus 5 to the 1/2. And I'm going to add this entire quantity to both sides. And that will give me, on the right side, x plus 13 to the 1/2. To eliminate both of these fractions, I can take each side and raise it to a power of 2. And when I do, that will eliminate the fraction here. And that gives me 3x plus 5 equals, and I can eliminate the fraction here, giving me x plus 13. Now I can just solve this linear equation. Subtract x on both sides, gives me 2x. Subtract 5 on both sides, gives me 8. Divide by 2, x equals 4. Now we have to determine if that's extraneous or not. So we need to substitute back in. 4 times 3 is 12. 12 plus 5 is the square root of 17, or 17 to the 1/2 power. minus 4. 4 plus 13 is 17 to the 1/2 power minus the square root of 17. The square root of 17 minus the square root of 17 is 0. Therefore, that is a solution of our equation. Again, we want to solve. This is very similar to the last problem, but instead of fraction quantities, we have these in square roots, which is meaning the same thing, just a different symbol. So again, I'm going to put one of these quantities on the other side, and I'm going to choose this one because all I need to do is add it to both sides, and that way they'll both be positive. So I'm going to have the square root of 5x. Add this quantity to both sides. That will eliminate it here, and that will give me the square root of 3x plus 6. Now I can, again, square both sides, raise it to the second power. That gives me 5x equals 3x plus 6. Solve the linear equation by subtracting 3x on both sides. Gives me 2x equals 6, or x equals 3. Substitute back in. That gives me 3 times 5 is the square root of 15, minus 3 times 3 is 9 plus 6, which is the square root of 15. The square root of 15 minus the square root of 15 is 0. Therefore, that is a solution. Again, this problem is very similar to the last two. So I want to take this quantity and move it to the right by adding it to both sides. That's going to give me x plus 6 to the 1/2 equal to x plus 6 to the 1/4. Now I want to raise each side to the same power, but a power that is both divisible by 2 or 4. That would be their common denominator. The common denominator is 4. So 2 will go into 4 evenly, and 4 will go into 4 evenly. So when I multiply 1/2 times 4, I get x plus 6, and 1/2 times 4 is 2. So that quantity is squared, and x plus 6, and 1/4 times 4 is just 1. So we get x plus 6. Now I have to find the product of linear factors. So I'm going to break that into x plus 6 times x plus 6 in FOIL. And when I do and multiply, I'm going to get x squared plus 12x plus 36. We have shown that in the last couple of slides. And that's going to equal x plus 6. It's quadratic. I'm going to bring these two quantities over here by subtracting x and subtracting 6 on both sides. That's going to give me x squared plus 11x plus 30 equals 0. Now I need to factor, and when I do, that's going to give me x, and I'm going to break that into 5 and 6, and 5 times 6 is 30, but 5 plus 6 is 11. It's going to be plus and plus, and when I set each to 0 and solve, that gives me x equals a -5, and x equals a -6. Now I have to check for extraneous solutions. Let's use a -5 first. A -5 plus 6 is 1. The square root of 1 is 1. And a -5 plus 6 and the 4th root of 1 is 1. 1 minus 1 is 0. So that is a solution. And -6. A -6 plus 6 is 0. The square root of 0 is 0. A -6 plus 6 is 0. The 4th root of 0 is 0. 0 minus 0 is 0. And that is a solution. So these are both solutions, and none are extraneous. In this problem, the time t in seconds that it takes an object to fall a distance of d feet from rest is given by the formula t equals the square root of 2d over g, where g is the acceleration due to gravity, and they want us to solve for d, find the value of d when g equals 32 feet per second squared, and when t is 3 seconds. So let's start with the formula, which is t equals the square root of 2d over g. They want us to solve for d, so we have to eliminate the square root. So I'm going to square both sides, something we've done in the previous slides. That gives me t squared equal to 2d over g. Solving for d, I want to multiply by g on both sides. Gives me g t squared equals 2d. When I divide by 2, that's going to give me d equal to g t squared over 2. Let's substitute our values given. into our equation that we solved for. D is equal to, G is 32 feet per second squared times T, which is going to give me 3 squared. It's going to give me 3s squared, which equals 9 seconds squared. So I'll substitute that in here, which will be 9 seconds squared over 1 all over 2. So D is equal to, the second squares cancel out, and 32 times 9 is 228 feet over 1 and 1. That just leaves 2 on the bottom. And 228 divided by 2 is 114 feet.